Hello and welcome to your video notes on Newton's second law and solving for force. So we're actually going to be looking at the numbers and the equations around what we've been talking about, which is force, which is again a push or a pull. You should already have your notebook set up so that you're ready to take notes. We're taking notes in Cornell Note style again, and you will need to pause this video to copy things down and then resume the video. And I will give you reminders of when you should pause. But every time I say pause, you need to pause and copy things down. Okay, so your first heading in your notes should be titled the equation. And the equation that we need to have is F equals ma. This is probably the most useful equation in all of physics. This equation is used over and over and over again and is really the basis of most physics problems from here well into college. So let's make sure we know what each of the letters means. First, we need to know that F is equal to force, m is equal to mass, and a is equal to acceleration. We've had acceleration already. We had that in our last unit. And just a reminder that acceleration means a change in motion. So getting faster or getting slower, or increase or decrease in speed. Force, we've been talking about, which is a push or a pull, and we've already talked about forces. A new word that we haven't had in physics class yet this year is mass. And mass is the measure of how much matter you have. Okay? So go ahead and pause the video right now and copy this down. Okay, so now what we're going to do is make sure that we know the units for all of these parts of our equation. So the first one that we're going to do is force is equal to newtons, named after Sir Isaac Newton, the scientist who came up with this equation. And it's really a simpler way to write out a really complicated version of units, which is kilograms times meters per second squared. So the kilograms here are coming from the mass, and the meters per second squared is coming from our acceleration. So together, that's a lot to write. So instead, we write newtons. But it's good to know what it actually is, just for a little FYI, which means for your information. Okay, so the other letter that we have in our equation is A, which stands for acceleration. And that is meters per second squared, which we write as m per s squared. And then finally we have mass. And mass is kilograms or kgs. Most of your problems are going to have it written as newtons, meters per second squared, and kilograms. And so those are really the ones that you need to memorize. So when you copy down your notes, highlight or circle or put a square around the three main ones that we'll see. Force for newtons, meters per second squared for acceleration, and kilograms for meters. This is another time to pause the video and copy all of this down into your notes. Once it's copied, press play again so you can move on to the next thing. Okay, so this is the first example problem that we're going to go over. And we're going to use the 5-step problem solving strategy again, which we've been using all year. So we should be really good at this already. Only thing is we have to make sure we know what equation we're going to use. So the equation that we're going to use is F equals ma. We always want to write down our equation. The next step we're going to do is we're going to collect our numbers. So we're going to have 10 kilograms, and we're going to have 2.3 meters per second squared. And now we need to figure out which one means what. So this kilogram and 10 kilograms is going to tell me that that is equal to my mass. So the kilograms tells me it's equal to the mass. And the meters per second squared is telling me that that's equal to acceleration. So I have that m is equal to 10 kilograms and a is equal to 2.3 meters per second squared. So now I'm going to substitute into F equals ma, and I don't have F, so that's going to be my question mark. So F is equal to 10 times 2.3, which is equal to 23. And remembering back to our previous slide, forces has a unit of newtons. So I'm going to put an N at the end of that. Pause this and copy down the work that I just showed you into your notes, and then press play again to go on to example problem number 2. Okay, so now we're moving on to example problem number 2. You've already written down example problem number 1. If you haven't written down any notes yet, go back and make sure you have all of your notes written down. Okay, new problem. Jose pulled an object with 5 newtons and has a mass of 18 kilograms. What is the object's acceleration? So again, I'm going to do my 5-step problem solving. I'm going to start with my numbers. So I know I have 5 newtons and I know I have 18 kilograms. The newtons tell me that that is force, and the kilograms tell me that it is a mass. It also tells me in the problem, okay, it pulled with 5 newtons. Remember, a pull or a push is a force. And here it says mass of 18 kilograms. So I can either look at my units or look at the word problem to tell me what these mean. The question asks, what is the object's acceleration? So that is my unknown. Because I'm dealing with forces, I'm going to use my force equation. F is equal to ma. I'm going to substitute now my 5 for my force and my 18 for my mass, and A is my unknown. So this time we have to do a little bit of algebra and solve for A. So to solve for A, we're going to divide both sides by 18. 18's cancel, and so I have 5 divided by 18. And I get an answer of 0.27, and that 7's repeating, so I'm just going to put the bar on top of that, meters per second squared. Now you may be asking, how do I know that my unit was meters per second squared? Well, the reason I know this is because I was looking for my acceleration. And my units for acceleration are meters per second squared. So I need to think about and go back and thinking about what is it that I am trying to solve for, and then I can figure out my units. Go ahead and pause here and write this down. When you're done, press play again and move on to problem number 3. Okay, so now we're on to example problem number 3. Dulce moved a table with a force of 15 newtons and a mass of 25 kilograms. What is the table's acceleration? So again, I'm going to write down my numbers. I have a force of 15 newtons. The problem told me right in there, it said force of 15 newtons. And the problem also tells me mass of 25 kilograms. So I'm going to say mass is equal to 25 kilograms. And I'm going to find out that the question's asking what is the table's acceleration. So A is my question mark. So I'm going to use the equation F equals MA. I'm going to substitute in again, so I have 15 equals 25A. I divide both sides by 25 to get A by itself. And so I get that A is equal to 0.6 meters per second squared. Again, the unit is coming from knowing what A's units are. Acceleration's units are meters per second squared. So I have to stop and think, what is my unit? And then make sure I put my unit down. And then put a box around my final answer. Okay, pause this, copy this example problem down in your notes, and then resume again for our final and last example problem. Okay, so now we're on to example number 4. Example problem number 4 reads that 2 is kicking a soccer ball with a force of 20 newtons, and it accelerated at 4 meters per second. What is the mass of the ball? So again, going to write down my numbers. So F is equal to 20 newtons. 2 reasons I know that. First reason is Newton means force, and my problem says force of 20 newtons. So 2 ways for me to know what that number meant. A is equal to 40 meters per second squared. 2 ways that I know that. Meters per second squared tells me that it's acceleration, and the story said accelerated at 40 meters per second squared. Last step is my unknown, which is my mass, is equal to my question mark. Using my equation, F equals ma, I'm going to substitute F, I'm going to put in 20. For mass, I don't know that. And my acceleration is equal to 40. And to follow suit with algebra, I'm going to write my number first and then my unknown variable second. But I'm still basically doing substitution. A is for 40, and then the m is kind of coming over here. So what I'm going to do is I'm going to divide by 40 for both sides to get my m. And then I get m is equal to 0.5 kilograms. Okay, and all of these problems, I'm assuming that you know some algebra. So here, this means 20 divided by 40. So I did 20 divided by 40 to get 0.5. Okay, so if you were confused in those other problems, that's what I was doing, is that I divided both sides and then I did the math, either in my head or in my calculator. Okay, so I'm going to put a box around my final answer. I'm also going to do a final check of my units. I'm finding mass, so that my unit is going to be kg. Okay, this concludes this video. Go ahead and pause or stop this video, and then I want you to write a summary, and in that summary I want you to write how you would solve for force, acceleration, and mass, and then write a couple questions on the left hand side, 3 questions that these notes will answer for you. Once you're done with that, go to your notebook page with the practice problems and start practicing those problems.